I believe you already submit the quiz 2 and 3, and he graded. As soon as he graded your any submission, it will be the grade result posted on the blackboard. You need to check. It's your responsibility. I guarantee, probably some of you, like the 2 or 3 students, will complain at the end of semester, even after you got the final. Why? I got the 0 mark for the quiz 1. I cannot remember even either he can. It's a long time ago. You should check as soon as possible. If something missed or something happened, just email him, then he can check it. It doesn't take a time. Okay, but if you complain after I submit the final grade, no, there's no way to find your submission or whatever. Okay, so quiz 2. Let's see. Do we have a signal over here?
Yeah.
Okay. Good. So quiz 2 is for ER modeling for university, not exactly university database. It's a student transcript. It's just a part of university database. Just for your reminder, what is the first step for the ER modeling? We need to find something. That something is what? The entities, right? Entity is the existing or important thing that should be organized in your database. For example, what about the university? Do you think the university is the entity?
No, it's the database.
That is the first mistake, common mistake by student. I believe university. Professor Lee said the entity is important. So university is, yes, it's important. However, in university, in this requirement description is your target one. You are going to build a university database. Okay? Then, using the requirement, you are going to decide the description of the university. So university is the target that you are going to model. Okay? Then to describe the university, what can be the candidate of your database, the entities? For example, the first A, keep track of student, something. Okay, so these are the whole description about the student. Then, what else? Then, for each department is described by blah blah blah. So department can be one entity. And what else? Then each course has, and also each section and a grade report has something. So we can find some candidates of the entities. So I think you memorize all of them. We are going to do. Yeah, thank you. So we have student, we have department, and we have course, we have section, we have grade report. We are not sure whether this is a strong entity, whether this is a weak entity until we identify key attribute. If we can identify key attribute, it will be strong entity. So there is no problem. Otherwise, in other words, if we cannot find the key attribute, which means we cannot identify the specific data entity, that will be weak entity. So at that time, we need to find the primary entity to get the key attribute. Okay? So first, student, what can be the key attribute? It has a student name, student number, social security number. Suppose student ID and SSN can be key attribute. However, in real life situation, real life database, not all students have the social security number like you. So I understand. So at that time, even this is the university database. We better use UBID as a key. instead rather than the social security number. Anyway, in general, we can use either of them. That means we have two key attributes. Later, we will select one of them as the primary key. If we do not know anything about the primary key, don't worry, we will learn later. Okay? So this is the key of student and so on. We have a bunch of different options as the attributes. Some of them can be composite, some of them can be the multivariate. And what about the department? It has a name. In the department, actually,
Code.
I don't think the university or company make the name with the same name, duplicate name. So we can use the name as the key, or even we have the number, code. For the department, we can use either of them. What about the course? Course has course name, can be what course number? We usually prefer number as the key, right? Because we have the, for example, character, letter, and number. If you were the computer, which one do you like? Actually, the number is easy to process, actually faster.
Yes.
Okay. So, but this is the logical modeling. It's a conceptual modeling. So we can have the multiple key attribute. And more attributes for this. Also section. We have instructor, semester, year, course, and section number. It depends. Sometimes section number can be the unique number. However, for example, UB, in case of UB, what is the section number of this course? It's 12, right? Probably there are many 12 named 12 sections in university. So we cannot use section number as the key. Instead, we should know what? Course number. But fortunately, in our description, each section has an instructor, semester, year, course, and section number. So we don't have to use identifying relationship in case there is a course number. But if we have the attribute course number, it's hard to manage. So if I were you, so I would like to use identifying relationship.
Weak entity and identifying relationship.
Then define this entity as a weak entity. Then borrow the course number to make the key of the section number. Okay? You can make the attribute for the course number here. Then make the strong entity. However, in this case, you need to check the consistency between this one and this one, right?
Yes, of course. The same.
For example, there's no registered course for database, but there is a section and database course name. However, DB is not registered in the course entity. Does it make sense? You understand what I'm saying? It's hard to manage. That is called the consistency. So we will use course number in course as the key. So we can use identifying relationship and weak entity. What about the grade? What is the attribute of grade? Student, section, letter grade, numeric grade. So we have the letter grade and numeric grade. What about the student? You can have student number, but it's the same problem.
From the
so we need to get
the student.
It can be identified.
Got it.
And also
Section.
number.
Translate.
This is one way. However, think about, so student can have the grade without registration. That doesn't make sense. So we can use this time ternary relationship. 1, 2, 3. Right? Student get the result grade from each section. This is the example of ternary relationship. Then, what is the key of this one? If you cannot find the key, so in this case we need student ID. That is student ID and section numbers. It can be weak entity in ternary relationship. Okay? And this is the grade. The other, I think pretty much straightforward. For example, student and department, it will be major and minor. Somebody may be curious, why don't we create the attribute for major? What about minor? It can be doable if we do not have department information. However, we have the department, the entity. At that time, we don't have to create the attribute for this. Okay? Also, why don't you read carefully the third line of let A, major department, minor department, if any. That means major department probably mandatory. So we can have full participation. Minor department is if any, that means partial. Okay, optional. Also, how many major departments in general? 1 or less. There are general subjects. So general can be considered as the major. So it's a full participation. Then it can be one-to-one relationship. Okay. What about one-to-one? No. One-to-many.
One-to-many.
Many students.
Sir, you are talking about participation.
Yes. So
not
cardinality ratio. It's a one-to-one or one-to-many or many-to-many. Which one?
One-to-many. No, with the
one in one department, how many students?
many
students. For each student, how many major departments? One. Which means it's a one to many. What about the minor? Sometimes you can have dual minors.
Yes.
One major computer science and minor electrical engineering and what is technical management.
It's optional.
If the department policy allows such a dual minors, it can be many to many. Otherwise, you can have at most one minor department or nothing.
Or nothing.
In that case, it's one to many. It depends on what? Policy, requirement, or common sense. That is not detailed in this description.
Yes.
Even in real life project, it's worse than this. They do not describe the requirement, just give you the policy or regulation or just a report. You need to identify such a rule. However, the problem is exam, your midterm exam. As you can see, there are many different ways actually. So in our exam, I try to my best to describe details or very clearly.
Yes.
However, that's not enough. That cannot be perfect. So it will be based on common sense between you and me. Like the major department is just one, and the name is unique for department, but student name may not be unique, something like that. Even though that is not mentioned. Also, even though if you have anything that you guess, you need to specify. You should take a note. I think there are many major departments, so I create many relationship, something like that in your exam. Can you understand? Okay. So this is the overall ER diagram for quiz 2. So then I think that this one will be the key point to create the ternary relationship. What about the quiz 3? a small news agency located in Sacramento County called Sec News. So pretty much it's quite easy, straightforward to create the ER diagram, except the picture. So let's see the picture. A picture has a number, so we can easily identify picture as an entity. So what can be the key? We have number. So this will be the key, and date, and height, and width, pretty much. Then, for the next line, for the picture, we distinguish between pictures that have been taken by a photographer working for Sec News and pictures that were bought by Sec News from other agencies. What does it mean? So are you going to create the new entities for this? Anyway, we already create entity for picture. Then the second line is for a picture. We distinguish, we classify. So for the picture, we distinguish. One is internal, another one is external. Internal picture, external picture. Then we need photographer and agency and price. Anyway, they are pictures, right? So at this time we can use what? Super and subclass. It can be generalization, it can be specialization. But in this case, we first find the picture, then specialize into two groups. Okay? We need to decide the two things. First, is it disjoint or overlap?
Disjoint.
It's clear. It's obvious. Why? Because first we have a picture, then classify either internal or external. There is no both of them, right?
Yes.
So it can be disjoint. Another one is full or partial.
Full. From picture to full. No.
Do you have any picture that does not belong to any of this? No. We classify into either internal, external. So it will be full participation. This is the picture of this. We need to find the key attribute over here. No, this is actually picture. So all attributes in superclass will be inherited to here. So automatically number will be key attribute. Number will be key attribute. Okay. That means we can create sometimes relationship between subclass and other entity. But I'm not sure in this example, but I'm not going to explain details of it here. The others are pretty much straightforward. Okay? Any question in quiz 2 and 3? So, sometimes your answer is different. I think mine is perfect, but mine is different from the Professor Lee's. Yes, definitely different. Depending on who, the model, the database, it can be various. Okay? The only difference is sometimes performance after you implement entire system. If you, for example, name can be just a simple attribute. Or sometimes it can be first name,
Composed.
middle name, initial, last name.
Composed.
How can we decide whether this is a composite or single?
Requirements.
Depending on requirement, also depending on analysis of your transaction application. If your application, for example, your input, this is a GUI environment, input interface. So first name, middle name, initial, last name, separately. Also you can search by last name, search by first name, search by middle name, initial. At that time, composite will be better. Otherwise, whenever you access the data, you need to segment or you need to find the server string. Okay? On the other hand, all your application actually use the name as one word. J. Lee, Jeongkyu Lee, J.K. Lee. It's just one word. At that time, you'd better use this. So depending on your application program or requirement, so performance will be different. Okay, but there is no general answer. But Professor Lee has the common answer, the general answer based on the common sense between you and me. But most time it works. Any question? I believe everybody can understand how it works. How can we model the database information using ER modeling? How to draw the ER diagram? The problem is your experience. So to improve your skill or to train by yourself, the best way is practice. You can find a bunch of examples from textbook, internet, and so on. So why don't you practice? Okay? Sometimes it's not easy because most of the question in exam or textbook is the description or requirement are well organized. It's fancy and nice. But in real case, it's very, very difficult to identify the entity, whether this is an entity or this is the attribute. Okay? If you do not have a question, we will move to the next chapter. So these are the information. So you are asked to build what? Finally, your final goal is to build a database. Then in your application program, you need to access such a data. Okay? This information is close to what? Human being. Like for example, in this kind of description, the university keep track of student name and blah blah blah. I can understand. Everybody can understand what the customer asks you to build a database. However, unfortunately, your computer system server cannot understand the description. That is the problem. But eventually, finally, we need to build what? Database system, which is running on computer. So your computer is not that smart, not smarter than you. That's the truth. So the only thing the computer understands is what? 0101 is structured format, data structure. That is the reason I keep emphasizing on data structure is the everything in computer science and computer engineering. Specifically, computer engineering deals with hardware structure. But computer science, like the database, is a purely data structure. Think about your programming language. CS390, CS400, all of them are actually data structure. It's the same problem. Yes. For example, in your programming language course, you are asked to build a program. Sum of 1 through 10. Okay? Everybody can do that. It will be 55. 1 plus 2 plus 3, 3 plus 3 is 6. What about computer? Computer can solve the problem when I ask first, what is the sum of 1 through 10? No, there's no computer who can sum up. Even supercomputer, no, cannot do that. Okay, why? It's a human language, it's a high-level language. It's a natural language. However, computer can understand only structured data, organized data. So how can we then code to the computer? We need to make data structure. For example, C program, main. It has a function structure. It will be the main function when you execute your program. Also, you need to define integer I, and I assign the initial value 1, then for loop and print. Even this is not easy for computer to understand. It's a human language almost. high-level language. What you guys need to do after you code it?
Run the program.
Run the program. Can you run the A.C file directly? No. You need to compile it. Okay? Then after you compile, what happens?
It will be generated the machine code. Well, object level.
What can be found at object file? A.O file.
Object file, of course.
It's a list of what? Machine language instructions. Series of instructions that can be
Converted to BX.
understood by computer, your processor. Processor is actually very simple. A plus B and store C. Or substrate. Or multiplication. That's it. So that is the instruction. We need to do the same thing when we develop the database system. So from the information, university keep track of blah 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 is a human language. So we did first time what? Data modeling. We found what is a modeling? It's a rule, policy, or constraint. Group of rules. We need to find something rule from description using what? Entity relationship model. So ER model. So we have this kind of the ER diagram for this information. It's one step forward to computer structured data, but still very far from computer. Do you think computer can understand this diagram? Definitely not. But better than this, but still very far from machine understandable language. So we need to jump to the computer. We need to make something more organized. Data, okay? That is called database modeling. Database modeling is, this is called data modeling. And this is called database modeling. To learn this one, we make the executable file program that includes the algorithm of this one. Sum of 1 through 10. Similarly, we need something, a program, software that can handle this kind of requirement. What is the requirement? Managing the database. Our goal is, the main objective of this course is manage data. What kind of data? Very large data, not important data. For example, if we are saying just the database managed important data, what about the social security number for me? It's very important. So because of that, I spend 100K, 100,000 to purchase the system and the Oracle database and insert only social security number. That doesn't make sense. So usually, most of case, the database system deals with very large data. Okay? So to manage, that is the goal of this system. But this system unfortunately cannot understand your database description. So we need data model, but still very hard to understand. We need to make something data structure, rules, or model to build a database. Okay? That is the blueprint of your house. Okay? Blueprint of your database system from computer. That is called database modeling. For example, if we are going to use object-oriented concept to manage such a data. So in computer, you already learned the object-oriented programming, right? Or conceptual or programming. So we regard data or entity as an object, like the student object. So we use. So based on your knowledge on the object-oriented programming, you can create something object for student and create the method and so on. That is basis of what? Object-oriented database model. Or you can think about some hierarchy model. We have bank. We have a branch. Branch. We have the staff, manager, customer. Customer has account and loan account, checking account, and so on. When you search your account first, which branch has your account, customer information, then from the customer, each account has your information, something like that. It's a hierarchy. It's kind of a tree. So we can use such a structure, hierarchy structure or tree structure to build a database. That's called a hierarchical database model. Others. We can understand such a database as a network. I never used the network database, so that's enough. So actually the network database model is not popular, even not popular, almost nobody used network database model right now. So I learned only from the textbook, frankly speaking, even I do not see any real database system. But hierarchical model is still used. Object-oriented model, try to do best one, first one, but not yet. Then, in this semester, we are going to use different database modeling that is called relational database model. So probably you heard about the RDB, or relational database model. Have you ever searched careerbuilder.com or the dice.com? You will find a bunch of the job description asking 5 years relational database model or the 5 years RDB. What are relational? What does the relational mean? Anyone? Yes.
It has the entities has relations between each other.
That is relationship, not relational. Actually, that is the most common mistake. Relation. When we are saying the relational model, relational database, relation does not mean the relationship between you and me or between entities, between whatever. That is the relationship in ER diagram. Okay, here. Relation of in relational database model means is a set. What is a set? Group of elements. Good answer. A set is a group of elements. Probably, why don't you go back to your elementary school, 3rd grade, 1st grade? In my experience, I learned it was the 3rd grade when I learned the first time set theory. That is 1, 2, 3. How many elements this set has? 3. And also another way to represent the set is x bar x bigger than 0, x is integer, something like that, right? So you probably learned this one. Also, this is empty set. Also, this is an empty set, but this is not the empty set, right? The most popular question. Most popular question in your elementary school, right? So this is a set theory that you learn. Then, why do I mention about the set here? Why don't we consider the modeled data here? This entity, relationship, and attribute. Why don't we consider such a group of entities as a set? It's quite similar. For example, so we identify so many entities for student. Lee and CSE and 111 and DQ7 Power View, so and Pattern, Electrical Engineering and 222 and 100 University Avenue and James, Technical Management and 333 and 1 and the North Avenue and so on. This is a student entity, student entity, student entity. Then they are the same format, same organization. So we identify this is for name, this is for major, and this is for the UVID. This is for address. Then this is called entity type. So these are the entity set. Right? That's what we did in the ER modeling. So this is a student entity. Why don't you take a look at this one? This is kind of one element, one entity, one element for Lee. This is for an element for Patel. This is for element for James. Then why don't we group as he answered? A set is group of elements, group of entities. Each element has the same format. Then this is a set for student. We can regard each entity as a set. Why? What is the benefit? Because these are already structured. In other words, computer can understand this structured data easily. Like we can use array to define. Or we can use the vector in terms of Java. We can use something struct in C program. We can use such a structured format to explain, to store, to define this data. The set. It's easy. Mathematics is close to the computer. So that is the reason we can consider the set theory to define the modeled data. That is the relational data. Why name is relation? Actually, set is the same as relation. In 1970, Dr. E.F. Court and IBM T.J. Watson Center, he proposed the relational database model first time. He considered, third, why don't we use the set theory to manage the data? Because set theory is easy to structure. Also, it's a very powerful operation. Set theory, I learned the set theory first time in my sophomore. Actually, my major is mathematics, so I learned the set theory first time. It described a very, very basic concept of mathematics. Like for example, it defined integer. Also, it proved any number will be 0 when you multiply by 0. You can prove it. So you can learn such a basic concept of the mathematics then in set theory. So we can use a very powerful set operation when we manage the data. That is set theory. Then why Dr. E.F. Court, who proposed this one, do not use the set? It's too popular. Okay, so he wanna make the different name, that is relation. So that is the reason his modeling, this modeling is called as relational model, not relationship model. Okay, so relational model is a set model. So we are going to use the set to define the data, just like object in object-oriented database. In object-oriented concept, we regard all the data type or the structure as an object. Similarly, we can use a set for the data. That is a relational database. So we already learned the definition of the relation. What is a relation? It's a group of
set elements.
Elements, but element is in set theory. Is a data or row. Also, we are going to use different name. For this is called tuple. T-U-P-L-E. I think you cannot find the definition tuple from dictionary. This is only for relational database. Okay? So this is each one is called a tuple. So, student relation is a set of what? Tuples. Also, set of each data. Also, sometimes we can consider
Instance.
each line as an instance or row.
Or record.
Right?
As simplified. Record.
So this is a set of data, set of tuples, set of instance, set of entity, set of rows. On the other hand, student can be described by what? Attribute. What kind of attribute here? Name, the major, ID, and address. So on the other hand, the relation can be defined as a set of attribute or a set of, this is called column. It's a table format, tabular format, right? Row, column. So set of column. So this is the basic of relational model. So relation is the basic component in relational database. Okay, that relation is a set of what? Tuples, set of data, set of rows, set of instance, whatever. Also set of attribute, set of column. So these are the relation. We are going to use this concept. As you can see, this is the two-dimensional table style, right? So we can easily code and make the data structure for this relation, for this table, for this whatever.
So,
Yes.
Is it easier to call it like Microsoft always call it like just a table, fields, records? Isn't it much easier to all the concepts and definitions? Now
For all the Microsoft product, or the you are saying only the SQL Server?
It can apply for any database.
So actually the
now we have like at least 3 or 4 names for the row itself. Tuple, row,
yes.
Instance, and you can
So
name it, of course, record.
usually there are 2 types of the terminology. I will show you later. I will explain. First, I'm going to, so relational model. So relational model actually proposed right after I was born. So I lived 5 decades. Really, 60, 70, 80, 90. So to the 21st century. Oh, this is 2010, 6th decade. I lived the 6th decade. So I was born in 69. So just before Neil Armstrong, the touch on the moon. So I can remember when I was 5 months old. 5 months. So somebody touched the moon and jumped. Can you remember that? Is there anyone? So anyway, right after that, in 1970, so one of the researchers in IBM T.J. Watson Center, so he proposed a new concept, new design. Until that time, only the hierarchical model or the network model. Hierarchical model is still very popular in the bank, the database, or financial system, because it's very easy to access the data, but it's very hard to combine or to represent a complicated relationship. Network, not sure, but somebody said it's not very good to represent a complicated one. So he thought about the set theory that I explained. Why don't we adapt the idea of set theory to the database management, database model? That is the paper. It's one of the best paper in computer science. At that time, he used the formal definition of the relation, his model. What is a formal? Formal means formal. It's the opposite of informal. What is informal? Yes?
Formal is like mathematical.
Yes, formal means mathematical because Professor Lee is formal, his major is mathematics. So I don't wanna, it makes sense. Anyway, formal means the mathematical way. Then informal means non-mathematical way. So far I explained the definition of relation using informal way. So informal way, the relation is a set of rows, set of data, set of what, and group of columns. Can I explain everything? Every definition of every example of the relation in worldwide? No, definitely not. Okay? But it's easy to understand. You can imagine what it is. Or, for example, I found the rule 8 times 0 should be 0. So I can prove it. 1 times 0 is 0, 2 times 0 is 0, and how many times? I did it 10,000 times. Still, that's not enough. Who knows? 100 times 0 will be something, not 0. So that is actually informal way. You can give the example or description. However, that cannot be acceptable in academia. Okay? To prove it, you should prove using the existing theorem or knowledge or mathematical way. That is a formal definition. In formal definition, we said instead of data or rows, we are saying tuples. So when you read the paper, technical paper, you will see a lot of formal definition, like the relation or the tuples. They are not using rows. Okay? They are not using column. Column is informal definition, informal way. Instead, attribute. Okay? That is the difference. So most commercialized product familiar with, they like informal definition, not formal definition. Okay? That's the difference. But actually, the meaning are not different a lot. So each tuple has the value, like this one. For example, this is the customer. Customer, this is one tuple, one example, one data, one row, 632895 customer ID. Name is John Smith, address, and the phone number. At that time, when you pick up the value of each the attribute, there should be something rules. We cannot use 11112222333333. There might be something format, right, for the phone number. Also, there might be something format for the address. There might be very strict format of customer ID, 6-digit number. We cannot use a 111111 10-digit number for customer ID. At that time, when you pick up the value, there might be pool of data that satisfy with the condition, like the only 6-digit number. This is the pool of customer ID that satisfy with the rule, 6-digit number. For example, 111111, 111112, 111113. This is called what? Domain. So this is the domain for customer ID. So there is another domain for name. Okay? There is another domain for this. So you can pick up the value from such a domain. Eventually that domain will be data type in computer. Computer actually cannot take care of all the possible data. Instead, we need more specified rule or structure that is called the data type. So, for example, 6-digit number, the data type is easy to code, right? You can use integer 6 or number 6 or even character 6. Like this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-digit character. This maximum 40 digit, not digit, 40 character. Okay? What about this? This is 1, 2, 3, 10 digit number. 3 by 3 by 4. Okay?
Professor?
Okay, that is called the data type, but in formal definition, according to the formal definition, it's called the data domain. But in commercialized software, they do not implement, they do not use the domain because domain is huge. We can easily imagine, right? Pool of data, right? 6 digits. You can put all the data in your brain, then pick up one value for the customized. But computer, they need to take care of all the possible data. No. Instead, they try to limit the data type. So this domain will be implemented in data type by the data type in commercialized software. Yes.
Professor, so the domain is the instance itself?
No.
Or just an attribute?
All possible value for custom ID. You have the custom ID domain. In this domain, you have all the possible value for custom ID.
Okay.
However, there's too many. So you cannot keep such a data in your computer. Instead, in your computer, you specify what? Very detailed data type, data structure. That is called the data type. Integer, 6 digit. Okay, something like that. So domain is the first time it's a little bit hard, but when he proposed, because when he proposed relational database model first time, he cannot use only the informal way, like the past. So he probably thought about a lot how to limit the possible value. So he defined the domain. Why don't we limit the possible data? Even that's too hard to implement in computers. So eventually later we use the data type. Otherwise, for example, we may have the many different values for this. Okay? So this is the name, this is a social, it's a very strict rule, and home phone number, and this is a, for example, 7-digit number. So we can pick up one value from the domain. So we can finally define the relation as relation R is a group of attributes, right? It's so simple. We do not have to provide the whole possible tons of thousands, millions of examples. Instead, just one line. Relation R is set of attributes. Even one tuple, the small r indicate one tuple, is a subset of domain A1. We can pick up one possible value from A1 domain, then combine with possible value from domain 2. That's the tuple. So 2 lines is enough to define.